Hey guys, what's up everyone? So in this video we'll discuss about the part 2 for minimum path sum. So in case you haven't watched the part 1, you can just go in the description section. I'll just link it down over there. So initially I wasn't planning on introducing a second part for this question, but actually I received a very intriguing comment on my previous video. So let me show you guys that comment. So basically Wasim says in the second point, if you start from the bottom and move up and left, then DP arrays can be reduced in size. DP to n will be sufficient since we don't need row n after we have processed row n minus 1. So basically what he's saying is we can reduce the space complexity of this problem. So let us see how. So basically this is a top-down DP solution and we have to convert this top-down DP solution to bottom-up DP solution first. So in case you guys have doubts about top-down DP and bottom-up DP, you can just Google it up and I can give a brief about it. So basically, whenever you are writing a recursive method and you are having overlapping subproblems. What is overlapping subproblems? So for this recursion, suppose, as you can see, F21 is called multiple times over here, and over here. So instead of calling recursion over it again and again, what we can do is when it's called for the first time, we will just store this value. And when it is called for the second time, we will just use that stored value only. So this is what we are doing over here in the DP array. This is the lookup table. So what we are doing is we are storing the value at I comma j over here. And before calling recursion, we are checking whether the value is not minus 1. That is, in case we have set the value for I comma j, we will just return that value. So in top-down DP, what we do is we introduce the DP array in the recursion itself. Okay. In bottoms of DP, we have to fill the DP array on our own line by line. So okay, so let me just comment this code and let me write the code for it. Okay, one thing to note over here is we have to increment the count of row by 1 and the count of column by 1 for the DP array. Why is that? See, for the top-down DP, you do not have to store the result for DPIJ for the base cases. As you can see, this is O1 complexity. This is again O1 complexity. So in case I write dp of ij equals integer.max value over here, so it won't make a difference in the time complexity. So we do not write dp of ij equals integer.max value over here and dp of ij equals grid of ij over here. We will just simply return the value. But in case of bottom-up DP, we have to consider this case. So we have to have this thing in the DP array itself. So what it says is if I equal grid dot length or j equal grid 0 dot length, in that case we are returning this. So we need to handle this base case inside the DP array. So that's why we are increment the row by 1 and column by 1. Okay. So let me do some things. First of all, int m equals grid dot length, int n equals grid 0 dot length, and we can simply say this is m and this is n. One more thing, so before doing anything you can just check whether the grid is null or grid dot length equal 0. In that case you can just simply return 0. Okay, now we have to fill the DP array. So as you can see in the recursive method, we have called it for 0, 0 over here. So in the DP array, our answer will lie in 0, 0 only. So let me show you guys something. So in case this is the grid array, as you can see, this is 3 cross 3. So DP array is going to be 4 cross 4. So the answer is going to lie over here. Now we will fill the DP array from the opposite corner, that is from here. So we can go row wise and we can go column wise. That is, we can fill this row like this, in this way, from the left to the left hand side, then this row, similarly this row, and similarly this row. And our answer will lie over here. And similarly we can do it column wise as well. That is, we can go like this, then like this, then like this, then like this. Both the same. I'll just go row wise. So let me just write the code for it. So for int I equals m, I greater than equals 0, I minus minus, for int j equals n, j greater than equals 0, j minus minus. Okay, so now what we have to do is, okay, we have to write these base cases over here. So as you can see, if I equal grid dot length or j equal grid 0 dot length, we are returning this value. So what we can say is, if I equal grid dot length, that is m, or j equal grid 0 dot length, which is n, in that case dp of ij will have integer dot max value. Similarly, the second case, else if, so I equal grid dot length minus 1 and j equal grid 0 dot length minus 1. So else if I equal grid dot length minus 1, which is m minus 1, and j equal n minus 1, in that case dp of ij equals grid of ij. And else we have to use this thing, that is dp of ij. We are calling the recursive method for I plus 1j and ij plus 1. So what we'll do over here is dp of ij equals math dot min of dp of I plus 1 j dp of I j plus 1 plus grid of I j, and after the loop is over, we can simply return dp of 0 0. Okay, so let us try to run this code first. So it's getting accepted. So let me just delete this method, as we do not require this method and we do not require this thing as well. Just to make things clear, let's submit this solution. So yeah, it got a success, as you can see. So let me just debug this code once for you guys. Okay. Okay, all right. So let's see. So as you can see, we are building the DP array from the top right corner, the bottom right corner. Okay, so if you see, so first I equals m and j equals n, and in case I is m or j is n, the dp of ij is integer max value. So we'll just say this is infinite, this will be infinite, this will be infinite, this will be infinite. Okay, in that case, now the I will decrement by 1, that is I will be equals to m minus 1. So we will reach over here and j will start from n. So we will reach over here, we will start from here. So again, this is going to be infinite only. So next, this value, as I equal m minus 1 and j equal n minus 1, this value is going to be grid of ij. So you can see grid of ij is 1 over here. So we'll just say this is 1. Now for this value, this will go in this else block, and for this dp of ij is math.min of dp of I plus 1j, which is this, and dp of ij plus 1, which is this. We will take the minimum of these, that is 1, and we will add the grid value to it. So this will be equals to 1 plus 2, 3. Similarly, the minimum value out of this is 3, and we will add the grid value over here. So 4, 3 plus 4 is 7. Again, this is going to be infinite. We will take the min value and add the grid value. So this will be 2. Min value is 2, grid value is 5, 2 plus 5, 7. Min value is 7 out of this, and the grid value is 1. So this will be 8. This is again going to be infinite. Min value out of this is 2. This value is 1. So 2 plus 1 is 3. Min value out of this is 3. 3 plus 3 is 6. Min value out of this is 6. Grid value is 1. So this is 7. So answer should be 7. As you can see, the answer to this test case is 7 only. So yeah, it's working correctly. Okay, so we have written the bottom up DP solution. Now what we will do is we will try to modify this solution so that our space complexity reduces. So currently, as you can see, the space complexity is what? This is equal to this. This is because of this DP array, so it will be m plus n cross n plus 1. Okay, so we have to reduce the space complexity. How can we do this? So while filling this DP array, you must have noted one thing. So when we fill this last row, after this we have filled this row. Okay, so in order to fill this row, we only require data from this row. Why I'm saying that? So this is infinite. For this, I took minimum of this and this, and I added the grid value to it. Similarly, for this value, I took the minimum out of this, and then added the grid value, and similar for this case. So we can say that in order to fill this row, we only needed this row. Similarly, in order to fill this row, we only needed this row only. So we can say that the current, in order to fill a row ith, we are only dependent on I plus 1. So when we fill this row, the 0th row, we only require this row, the data at this row. This data doesn't mean anything to me. Okay, so what I can do is I can reduce the space complexity. How I can reduce the space complexity? Now I'll reduce the number of rows. I'll reduce the number of rows to 2. Why? Because in order to fill the ith row, you only need data at I plus 1. So we will have the same number of columns, but the rows will be reduced to 2. So what I'm saying is, after this, okay, I'll create a DP array of size 2 cross 2. Means basically the number of rows is going to be 2. So we are going to create something like this. The number of rows are going to be 2 and the number of columns is same. So what we are doing is, so suppose we are filling this this row first. Let me just do one thing. Okay, so when we are filling this row, we will first fill this row, and in order to fill this row, we will only require data at this row. So once we have filled this row, what we will do is we will try to fill this row via this. Okay, so what we have to do is so we have to toggle it somewhere. So let me write the code for this and I'll try to explain it to you. So what I'm saying is, first of all, the number of rows are going to get decreased to 2. We'll have a flag value over here, which is set to 0. So we are not filling the DP ij, we will fill DP of flag j. So wherever there is I, just replace it by flag. Over here as well, DP of ij plus 1, so DP of flag j plus 1. So we won't be having I plus 1 now. What we will be having is flag zor 1. Okay, and we will toggling it over here. So as you can see, if flag is 0, so flag zor 1 is 1. When flag becomes 1, 1 zor 1 becomes 0. So this is going to toggle. So what's happening is, in the first round of this loop, we are going to fill DP of 0j. That is, we are going to fill this row. Okay, once we have filled this row, we will toggle the value of flag. That is, now flag will be equals to 1. So in the next cycle, we will try to fill the since flag is 1, we will try to fill DP of 1j, and we will take help of this thing. So 1 or 1 is 0, so we will take help of 0th row. So we will fill this row with the help of this thing, and same goes on and on and on. So the answer will not be over here, it will be at DP of flag zor 1 0. Okay, so because after the last iteration, the flag value will get toggled, so we have to toggle it again to point to the correct solution. So I guess that's going to be it. So let me just run the code first. So it got accepted. Let me submit the code. So yeah, we got a success. So this is a pretty good technique which is used in competitive programming, in which we can reduce the space complexity. So you might find questions on websites like Spodge, CodeChef, in which they won't take the solution unless you are doing this, that is, you're using this technique. So the basic concept is, whenever the DP array for any row is only dependent on the next row, we can reduce the space complexity. Okay, so I know it's a lengthy video, but I needed to explain this topic. So in case you have learned anything from the video, you can just hit that like button, and for future videos you can subscribe to my channel. Thank you.